Hey guys, it's Ms. Marflag here. We're continuing with derivatives today. You should be very, very excited because today is going to be our last kind of mandatory lesson. Our last lesson, we really will have to be submitting work for a grade. There'll still be some more videos to come, but today is going to be the last day where we're submitting for a grade. Just a quick reminder, the end of the marking period is this Friday, June 19th, and everything needs to be submitted the day before that on Thursday, June 18th. So make sure you get to work on this assignment right after the video. You don't procrastinate it because if it's late, it may not even get into the grade book for the fourth marking period. All right, so we've been doing this introduction to calculus. We did our limits and we spent our previous two lessons doing an introduction to derivatives. We went over generally maybe what a derivative is, and then really when we worked on these practice problems, what we were doing was finding the slope of a tangent line at a specific point A. So we know that the slope of the tangent line is the function's derivative. But what we did in our previous problems was find the slope of the tangent line at A. And now we're going to be doing, we're actually getting to the heart of calculus, and we're going to be working with derivatives. Now, the derivative, the main difference between what we're doing today and what we've done in the past is that today this derivative is going to be for the entire function, for any x value. So we're going to be able to find the derivative of a function and then decide what x value we want to find the slope of the tangent line. So we talked about how the derivative is the slope of the tangent line, and then we just have our definition from the textbook here. Let y equals f of x be a function f, then the derivative of f at x is this derivative formula and definition here. Now it looks very similar from our previous definition, the slope of a tangent line. Instead of a's, we have x's. So we just have that step now where we're not plugging in the a at the beginning, but instead we're going to be plugging it in at the end. So once again, this is a derivative which will be the slope of the tangent line, but we can use this derivative equation to find the slope of the tangent line at any x value we choose. Now we're going to take a look at our notation. And our notation, it may look like f1 of x, but it's not really a 1. We say f prime of x, and that's our derivative notation. And then the more primes we get, that will be like a second, a third, a fourth derivative, and so on. So this is what you could say f prime of x, or you can say the derivative is equal to this, but you really don't say f to the 1 of x, okay? It may look like that visually, but that's not how we read it. All right, and then we're going to jump into some practice problems, and we're only doing 3 practice problems today. And here's the first one, and we're asked to find the derivative of f of x. So that's our first step here, is to find the derivative of this function. Then once we have the derivative, we're going to find the slope of the tangent line. I don't know how I missed that. Of the tangent line at x equals -2. So let's get started with that derivative first. All right, so the first thing we're going to do is we know we're searching for the derivative, which is f prime of x. And we know our definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to do some substituting here. So I want to evaluate, I want f of x plus h. Well, here's my f of x, but instead of x's, I need x plus h, okay? So that's what I'm going to do here. So we still have this limit notation. And now I'm evaluating, and I have x plus h squared plus 3x plus h. So wherever I have an x, I take out the x and I replace it with x plus h. So f of x plus h is this whole thing. And then now we have minus f of x, and my f of x equation is this equation x squared plus 3x. Now you do have to be careful when you're doing the subtraction of the f of x. Make sure your whole f of x goes in parentheses because you're minusing the entire function, not just the first term. So you do have to make sure that goes in parentheses there, and then that's all over h. All right. This is the hardest part of the problem, knowing what to substitute in where. Everything after this is pretty much just algebra 1 and algebra 2, so let's review really quickly again. So we're evaluating f of x plus h, which means wherever I have an x, I replace it with x plus h. And I have x plus h squared plus 3x plus h. And then I'm minusing f of x, and my entire f of x is this expression here, x squared plus 3x. All right, and then now it's time to simplify. I still have this limit as h approaches 0 all the way through until we evaluate. Now you can do x plus h squared off to the side on a sticky note, but we've done that a lot in previous videos, and you should be pretty good at maybe just mentally foiling right now. If you're not, that's okay. Grab that sticky note or do it off to the side, but I can tell you that this is x squared plus 2xh plus h squared. If you're like, wait, what? Where'd you get that? Okay, take a second, go off to the side, expand this, and FOIL. All right, and then now we're going to distribute that 3, and we're also going to have to distribute that negative sign. So let's first distribute that 3. We have plus 3x plus 3h minus x squared minus 3x. And then that's going to be all over h. Now, I did leave this in parentheses, but I don't need the parentheses because I don't have any negative sign in front that I need to distribute. So we can go right ahead to combining some like terms. Okay, at this step, everything that just has an x should be crossing out with something else because we're going to just have h's left. So here, I can look at my combined like terms. I have x squared minus x squared. Okay, that's going to combine to 0. I have a positive 3x and a minus 3x. That's going to combine to 0. And then I can do this one more step of, simplifying, and I can see that I'm left with 2xh plus h squared plus 3h all over h. Now, keeping in mind that we're evaluating a limit here. We're solving for a limit algebraically, and we can't solve for a limit algebraically using direct substitution if we're in indeterminate form. And when I plug in that 0, I get 0 over 0. We're in indeterminate form. So I'm going to use one of my strategies to simplify this, and that strategy was factoring. So I'm going to take out that h. I'm going to factor it on out. And we're going to have h times 2x plus h plus 3 all over h. And that's going to get rid of that 0 in the denominator, which is really what's causing that indeterminate form. And then fully simplified here, we have 2x plus h plus 3. And then now I'm at a place where I'm allowed to solve the limit using direct substitution. So we're going to substitute in that h equals 0. And once we substitute that in, that limit notation goes away. And then I could kind of peek back and recall what I was solving for. I was solving for the derivative. All right, so this final answer here is my derivative. All right, now I can take a look back at my function, and my function was x squared plus 3x. When you get further into calculus, you're going to be solving for the derivative using rules. We do like bring the 2 to the front, drop down a power, bring the 1 to the front, and then drop down a power. This becomes x to the 0, and then the x is gone, and we're left with 2x plus 3. Okay, but we're using here the strategy of solving using limits. So my final answer here is the derivative of x squared plus 3x is the function 2x plus 3. Now this derivative, keeping in mind a derivative is the slope of the tangent line. This will give us the slope of a tangent line at any x value, and then I go back to my problem and I want to know what's the slope of the tangent line at x equals -2. Okay, well that means the slope of the tangent line would be my derivative. So the slope of the tangent line at x equals -2, I evaluate at -2. And I'm going to get here -4 plus 3, and I'm going to get -1. And I could tell that this is my m slope of the tangent line at x equals -2. Now this is really helpful because when we did the f of a, we would have plugged in the a as -2 from the beginning. But now we could do it at any x value and we could still use the same derivative. And if you go back to our introduction of derivatives, I said at the very beginning that derivative is going to be an equation or a function. And then you'll be able to plug in your desired x value for that instantaneous rate of change, which is the slope of your tangent line. So there's that function. I'm plugging in my desired x value and I'm getting that instantaneous rate of change at that exact x value. Now you could go one step further. We're not going to go further in this video, but I could ask you what is the equation for the entire tangent line. Now this just gives you the slope. So I know the slope is -1. I know my x value is 2. I could plug in my x value. I know my x value is -2. I could plug in -2. I get 4. Plus a -6. And I can get my y value, and then I have an x value, y value, and a slope, and I can write a point slope form equation, but we're not going to do that. All right, so here, really quickly, what we did was we just used a derivative definition. We got the derivative and then plugged in the x value. All right, so I talked a lot with this first example. I promise I won't do that amount of talking in number 2 and number 3. All right, here we are. Given f of x is 4 over x, find f prime of x. So we know that this means now that notation means derivative. And then I want to find the slope of the tangent line at x equals, -2 again. Perfect. Okay, so we're going to start off with our equation. Well, I know the derivative of a function is equal to f of x plus h minus f of x all over h. So we're going to do some substituting in. Wherever I've got x, I'm going to take it out. I'm going to put in x plus h. So I have 4 over x plus h. And then I'm going to minus f of x, and my entire f of x is 4 over x, and then that's going to be all over h. Oh, I'm forgetting my limit. I don't want to redo this video. Okay, I'm going to make it look ugly. That's okay, though. Hopefully you guys forgive me. My definition has my limit as h approaches 0 of f of x plus h minus f of x all over h. All right, and then now when we go to substitute in, we have the limit as h approaches 0 of 4 over x plus h minus 4 over x all over h. All right, so we substituted in the x plus h minus our f of x equation, which is 4 over x. We know that this limit is in determinate form, so we need to use one of our algebraic rules for simplifying. In our previous example, what we did was expand and then factor. In this example, we need to combine fractions. So I need a common denominator here, so I'm going to multiply this fraction by this denominator, and I'm going to multiply this fraction by this denominator, which is x plus h over x plus h. Now, if you can do this algebra in 1 or 2 steps, go for it. I'm going to, do every little step at one at a time. So first, we're going to distribute in that x. I'm going to have 4x over x plus h, minus 4x plus h over x times x plus h, and then that's going to be all over h. And then now I can see up in the numerator, I have the same denominator, which means that I can combine fractions. So I could do 4x minus, and then let's distribute at the same time. Okay, so I can distribute that -4, okay, and I'm going to have minus 4x minus 4h, and then my denominator is x over x plus h, and then that's still over h. All right, so all I did was I saw that these two had the same denominator, and I combined up in the numerator and distributed that -4 there. And then now I see up in my numerator that I have positive 4x minus 4x, and I'm going to see that I'm going to be left with here up in the numerator, those combine to 0. I'm left with minus 4h all over that common denominator, x times x plus h. And then now I can do that keep, change, flip. So I'm going to change this division to multiplication. And I'm going to take the reciprocal of h over 1, and that's going to be 1 over h. And then I can see here I have h divided by h, and I can get rid of those two. And then now my fully simplified limit is -4 over x times x plus h. Now I'm at a point where I got rid of that h in the denominator, so I got out of indeterminate form, which was kind of the whole goal. So now I can evaluate getting rid of that limit notation, and wherever I have an h, I'm going to plug in 0. And then I simplify here of -4 over, and you would not believe how many people give me 2x here. Okay, x times x is x squared. And then that's my derivative, f prime of x. So I could say the derivative of 4 over x is -4 over x squared, and you're going to learn a rule for that as well, so you won't have to do all of this work when you get to calculus. All right, and then now our second part of the problem is I want the slope of the tangent line at x equals -2. Okay, well, I know the slope of the tangent line is my derivative. And now I'm going to use my derivative equation to give me the slope of the tangent line at a very specific x value, and that x value is -2. Be careful with your signs here. So I have -4 over -2 squared. -2 squared is +4. -4 divided by +4 is -1, and there we are. Now, I do think we did this example problem together using the f of a, and I gave you a coordinate point, and we got the same answer in a previous video. All right, here's the last one, number 3 that we're doing together. Yay! And our directions here, you guessed it, find the derivative of f of x equals x squared minus 5x, and then find the slope of the tangent line at this x value. Okay, so our first step is always to write out that definition. I forgot the limit in the last one, and I'm not going to forget it here. So the limit as h approaches 0 of f of x plus h minus f of x, and that's going to be all over h. All right, so you have f of x plus h. Okay, so wherever I have an x, I'm going to be putting in x plus h. Wherever I have an x, I'm going to be putting in x plus h. So we have x plus h squared minus 5 times x plus h. And that's just f of x plus h. That's this. So then I still have minus f of x, and that whole expression for f of x has to go in parentheses because we do have to ensure that that's getting distributed. All right, now we have a lot to do here up in the numerator. The first thing we're going to do is expand. You could do it off to the side. I'm going to do it right here, and that's going to be x squared plus 2xh plus h squared. And then I can distribute this negative 5. And then I can distribute this negative as well. So let's first do that negative 5. And I'm going to have minus 5x minus 5h. And let's distribute that negative minus x squared plus 5x. And then that's all over h. And then we got a lot of terms up in the numerator. So let's see what we can combine with like terms. I have a positive x squared and a minus x squared. That combines to 0. I have a positive 5x and a negative 5x. That combines to 0. And then now all I'm left with here, after I combine some like terms, is 2xh plus h squared minus 5h all over h. And then we're still in indeterminate form here, so I'm going to use one of my algebraic strategies, and that one is going to be to factor out an h. So I have 2x plus h minus 5, and then h over h is 1. And then I can plug in h equals 0, and then once I plug it in, I'll write this out simplified first. 2x plus h minus 5. Once I plug in h equals 0, that, limit notation goes away, and then there's my derivative for this one. F prime of x is equal to 2x minus 5. And then, like I said, you're going to learn your power rule. You bring the 2 to the front, you drop the 2 down by a power, you bring the 1 to the front to multiply, and the x drops down to x to the 0, which is 1, and you're left with 2x minus 5. But you don't need to know that right now. All right, and then my goal is to find the slope of the tangent line. Okay, I know the slope of the tangent line is my derivative, which is 2x minus 5. So I'm going to evaluate my slope of the tangent line at x equals negative 1. And we're going to simplify. We're going to have 2 times negative 1 is negative 2 minus 5. And the slope of the tangent line at that specific x value is negative 7. All right, that's all I got for you today. This video was a little longer than I kind of hoped it'd be, but at least you saw 3 examples of now actually doing derivatives with the x's in them. You're definitely going to see this next year in calculus. There will be some more videos to come, but keep in mind the end of the marking period is the 19th, and this is definitely our last day of doing some mandatory work that has to be submitted. All right, so email me if you have any questions. Do not procrastinate on this assignment, and you need to get this one in on time. The marking period is ending, all right? Email me if you have any questions. Bye, guys.